Okay, in this video we're going to have a look at the effect of changing pressure on a reaction that's a reversible reaction and it's at the dynamic equilibrium. Remember, that means the rate of the forward reaction and the backward reaction are the same. Okay, so I'm just using here some examples of A, B and C and D, and just to help me explain this to you. And then later on in further videos we'll look at using real life examples of chemical reactions. So if we're looking at pressure, then the factor we have to consider in this reaction is how many molecules, how many moles of these gases we have on each side. Okay, and we'll add those up and then I'll explain why. So this side we have got 2 moles of A and 4 moles of B. So here we have got 6 molecules on this side, and over here we've got 3 of C and 1 of D. So we have got 4 moles, 4 molecules of gas on this side. The reason we have to think about the amounts of molecules, if we just slide this up, I will show you, is imagine you had a balloon and your balloon was full of molecules of gas. Okay, the balloon, the pressure inside the balloon is created when these molecules bump into each other and bump into the side of the balloon, and that creates the pressure that inflates the balloon. If I had a second balloon that had less or fewer particles inside it, then you can see there would be less collisions with the side of the balloon and with other particles inside here, and therefore, because there's less collisions going on, the pressure in this balloon would be less, would be lower. Okay, whereas the pressure in this balloon, because there's more particles, would be a higher pressure. So the pressure in a system is linked to the number of particles you've got, number of moles you've got, number of molecules you've got. The greater the number of particles, the higher the pressure is going to be. So if we go back to our example here, you can see that at the moment there are 6 moles, 6 molecules here, 4 moles, 4 molecules here. Therefore, because there's more molecules on this side, we have a higher pressure, and this side will be a lower pressure. Okay, and we need to know that now when we're going to start to change these conditions. So we've done our first little bit, and then this activity says in this reaction we are going to increase the pressure on the reaction, and it wants to understand which way will this equilibrium shift. So we're forcing a change on a reaction, and if you remember Le Chatelier's principle, we'll slide it back in. Le Chatelier's principle says that when we've got a reaction at equilibrium, it will go against any change that we impose on it. So in this example, if we are going to try and increase the pressure, so we are going to try and increase the pressure, then according to Le Chatelier's principle, I'm going to just shorten that to save me a bit of space here. According to Le Chatelier's principle, the reaction is going to try and lower the pressure. It's going to do the opposite to what we are trying to do. Remember teenager's law, do the opposite of what we're trying to do. So how is it going to do this? How is it going to lower the pressure? Well, the way to lower the pressure is to move to the side that has the lower pressure, and that is because it has less molecules, less moles of product. Okay, so in this case, this reaction is going to try and move towards the right. The way we say that is we can say that the equilibrium will move to the right. Okay, so the equilibrium is going to move to the right. I'm going to carry on my explanation. Why is it going to move to the right? Because the right hand side, there are fewer moles. Okay, there are fewer moles, and therefore that's going to cause the pressure to drop because there's fewer moles. And if the pressure starts to drop, it's going to oppose this change. And if the reaction is going this way, then what happens is we start to make more of C and D. So here we'll get an increase in the amount of C and D as we start to make more of it. Okay, so let's just go through that again. So we've counted up how many moles, how many molecules of gas we've got using the balanced equation to do that. We've then identified that when you have more moles, you have a higher pressure. This side's got 4, therefore it's lower. The situation is it wants us to increase the pressure. So Le Chatelier's principle says when we impose this change, it will do the opposite. So it will try and lower the pressure. Go back up to here. Which side's got the lower pressure? It's going to be the right-hand side. So this reaction is going to move to the right. The equilibrium will move to the right because that's the lower pressure. And if it moves to the right, because there are fewer moles there, the amount of C and D will increase. Okay, I hope that makes sense of explaining a change in condition of pressure on the effect it has on the equilibrium position for this reaction.